So basically we have x plus y is greater than or equal to 2 root xy, yeah? Or another way of saying that is like the average of x and y is greater than or equal to the geometric average of x and y. Or the average using addition is always bigger than or equal to the average using multiplication. Okay, and it works for 3 variables as well.
Didn't we prove this for
Yeah, we took very long to prove it.
That's because you guys.
It was actually a nice proof.
Yeah, because I'm bad at
written
proving.
down.
Yes, because you guys.
Okay.
Dude,
So-
you like learned this a long time.
Just a reminder of what we're doing, right? So actually we've already proved the first one here, yeah?
We proved this one, right?
We've already proved this one, and it was just
Yeah.
simply using the first one
Yeah, so
3
it's-
times, yeah?
Yeah.
So a plus b is bigger than or equal to 2 root ab, yeah? B plus c is greater than or equal to 2 root bc,
You sub them in.
and a plus c is bigger than or equal to 2 root ac, and so if you times them all together, it's greater than or equal to, a, b, and c are always greater than 0, yeah? If you times them together, then it's greater than or equal to 8, and then all those things times together is just ABC. Yep. Okay.
Have my words arrived yet?
Yes.
Wrong.
Okay.
Your words are pen.
Okay, but then something that we didn't quite do last time.
Rearrangement
Just
inequality.
do it.
So maybe I'll go for this one first.
Show the rearrangement inequality.
So there was something like this. It was like a. So there's these 2 questions we didn't quite get to do. So we got a squared on b plus b squared on c plus c squared on d plus d squared on a, right? Is greater than or equal to a plus b plus c. I'm not going to go through this one today, but I will go through this one.
It's the same VM.
And then there's another one was a cubed. So this one is actually a good lesson to learn.
Oh, and this is the impossible.
A cubed plus b cubed plus c cubed is greater than or equal to a
This one's
squared
impossible.
b
Oh.
plus b squared c plus c squared a, yeah? And a, b, and c are always like positive, yeah? Okay,
Willog.
so maybe I'll tell you a little bit of a story,
Can we
okay?
induction this?
No, we use Willog.
Okay, wait, what?
We
No,
say A
but
is
you
greater than B is greater than C.
Okay, so I'm looking at the top question,
cannot
right?
log this one, it's not symmetrical.
So this is the story of the second question, okay? But the story of the second question started with the top question for some reason. Okay, so one way, like question 3 is hard, I guess, because there's 4 variables, yeah. And you know, one way to try to look at the problem more fundamentally, you can try and see what happens with 2 variables, yeah. You have a squared on b plus b squared on a, yeah.
It's greater than A plus B.
Is greater than or equal to a plus b, right?
Yeah.
And if you clear the denominators, right, then what you get
Yeah, but that's just
is
how
you
this
get
one is.
A squared plus B squared. A squared B. Wait, no. A cubed plus B cubed.
plus b cubed, yeah.
It's greater than A squared
Wait, Michael, that's
Yeah.
B.
that's a random question, but what's like the expectations for this maths program?
Expectations.
Like, how do they like choose people?
You get good.
Is either teacher nominations or like AMC AIMO scores.
Yeah.
Well, I'm bad, so I can't use that.
Teacher definitely didn't nominate me.
What did James? Did you get prize?
All right, these considerations. Let's keep them away from my classes,
And
okay?
and B squared.
Because I really don't care. Okay, so a cubed plus b cubed is greater than or equal to a squared b plus ab squared, right?
Yep.
Yeah. And I guess the crazy thing about this is like this sort of, I don't know, maybe, so one thing you can think about is like, maybe can you prove that a cubed plus b cubed so you can't quite prove that that's greater than a squared b, right? How do you sort of, can you prove a cubed plus b cubed is greater than or equal to a squared b? So maybe not. Yeah.
Um,
Hmm.
But if you add another a cubed, okay.
2a cubed plus.
See, the point is the a has like twice as many powers as the b, right?
Yeah.
Yeah. So maybe we can get twice as many a's as there are b's. Yeah. So what if we add another a cubed? Yeah. So if you add another a cubed, can you see that a cubed plus b cubed is greater than or equal to 3?
Yeah.
wait.
Because a cubed is always it's greater than or sorry. What was I saying?
Can you see that?
Yeah, because 2a squared is less than a cubed.
Yeah. So this last thing I just wrote comes from this AMGM. See, xy plus z, right? I make x a cubed, I make y a cubed, and I make z a b cubed. Yeah. Does that make sense?
Yeah.
So I can do the same thing again with the b cubed, right?
Well, and you add them together and you divide by 3.
3 ab squared, right?
Yeah.
Oh, big
Yeah.
brain.
So actually, this is a pretty important lesson in this kind of AMGM, because there's a certain intuition that this argument directly says. It's basically whenever you have powers of stuff, right? The a cubed, like the a cubed has only a's in it, right? Whereas like a squared b is sort of a mix, yeah. So the powers that are sort of not mixes, where they're like one thing with a big power, is always sort of bigger than the stuff which are more mixed, even if it's of the same sort of degree in the end, right? So even though there's two A's and one B and there's three things, having three A's is always sort of going to be bigger, yeah? And this is sort of the way to prove that intuition, yeah? Okay. So can you see if you just add these two inequalities, right? You get
3a cubed.
you get what we want,
Yeah.
but times by 3, yeah?
So can we just do the same thing for the a cubed plus b cubed plus 3c cubed?
Yeah, so the crazy thing is we're doing the small case of the first problem, but we end up solving the second problem, right? Yeah? Because the second problem is exactly that intuition, right? The cubes, when they're not mixed, is bigger than the cubes that are mixed. See? So how would you do that?
So then you can first prove that a cubed plus b cubed plus c cubed is greater than or equal to a squared b using the same method.
Yeah, so let me just write that somewhere.
Well, I mean, you can just ignore the c.
Okay, so can I recycle some of these? I can recycle this
You
one,
can
yeah?
recycle that one.
Yeah? I can't recycle the other one, yeah?
Hmm.
But I can, like, cycle the first one. Yeah. Cycle means A goes to B, B goes to C, and C goes to A.
Oh,
Yeah, because if you have that one and you add c squared, I mean, it's already greater than.
yeah.
Yes, it has to be.
And you have B cubed
But that's smart.
plus B cubed plus C cubed, yeah? Is greater than or equal to 3B squared C, yeah? Okay, and then
Doesn't that prove the top one as well?
Oh, wait.
well, maybe you guys can try the top one for
Yeah, because
yourselves.
if you clear the denominators, then you just get a squared. A cubed plus b cubed plus c cubed plus d cubed is greater than.
Yeah, I'll leave it to you, and you can tell me what happens with the top one, okay? So there's always one problem left behind, so you have something to strive towards. So, so B cubed. So then the other one is C cubed plus C cubed plus A cubed, yeah? It's greater than or equal to 3 C squared A. Yep. And so if you add them all together, right, it should be just 3 times that. Oh. Interesting. So in general, whenever you see like some like homogeneous, so they have the same powers on both sides when you add up the powers, but one of them is like not mixed and the other one's more mixed, then the not mixed one should be bigger than the mixed one. Okay. And you can also see this is kind of like the motivation behind having the idea of a weighted AMGM, right? So what do I mean by weighted AMGM? Like weighted. So what happened did we do? We put an extra c cube, like we put like a cubed twice, so it has an extra contribution, right? So weighted, like, so instead of having a cubed, b cubed in a three term AMGM, you can have just a cubed and b cubed in a sort of a 2-term weighted AMGM. Does that make sense? So if you have like, so it's basically like
Wait, how that?
So okay, so sorry, maybe it is still sort of like a 3. So it's 2/3 a cubed, yeah, plus 1/3 b cubed, yeah. And the point is 2/3 and 1/3 add up to 1, right? Before we'd have just had half and half, yeah. Let's see, that should be bigger than or equal to. It should be AB. So AB, and the powers should be the coefficients. So it should be A to the 2/3, B to the 1/3.
Wait.
So that's what you call like the weighted AMGM. Yeah.
Wait a minute. So that's.
This one's interesting.
Does that make sense?
Yeah.
So like having 3 of them, like we did AMGM with 3 things, right? But we basically used a cubed twice, right?
Yeah. Okay.
There's another way to kind of do it where you kind of, well, you're just using a cubed twice, so we'll just weight it differently in the two variable AMGM. Yeah.
Wait. What if we weight that?
Yeah. So this is called weighted AMGM, and I guess the thing is, it doesn't have to be like fractions, right? It can be any 2 numbers that add up to 1. It doesn't have to be like rational numbers. Yeah, so you can see that's exactly